Hey everyone, today in this video tutorial I am going to have a look over a sensor that is SI7050. To know more about this sensor, let's go to CONTROLEVERYTHING.com and here search for this sensor SI7050. So let's see what we got. So SI7050 is a high accuracy temperature sensor and these are some of its features which you can see on my screen. Today I am going to interface this sensor with an Arduino Nano, and for that a code is required. So go to Resource tab and here is our Arduino Code sample. You can download this Arduino Code sample as a zip file from this point, and you can also have this code from our GitHub repository, that is CONTROLEVERYTHINGCOMMUNITY. Now let's proceed further and make some connections for the hardware. Moving now for the hardware connections, first of all we require an Arduino Nano, and this is an I2C shield. This is very useful in making connections with other I2C devices and rather makes them very easy. This is available on our website CONTROLEVERYTHING.com. Please have a look over this. Now gently put over the Arduino Nano over the I2C shield and make this connection. For now, we require our sensor that is SI7050, and this is the connecting cable. Make the connection among the sensor and the cable like this, and while making this connection, please make sure that the brown wire of the cable should be connected to the brown terminal of the sensor, and similarly we have to follow the procedure for the I2C shield. Now, to power up our Arduino Nano, we require a mini USB cable just like this and gently insert it over here. So these are the connections we require for our tutorial, and let's proceed. For the interfacing of the sensor with the Arduino Nano, we require a code. So for that, go to GITHUB.com and here search for CONTROLEVERYTHINGCOMMUNITY, which you can see on my screen. Click on it and here type in SI7050, and here is our sensor, and this is our required Arduino code. Let's have a look over the instruction first. First of all, we have to download and install the Arduino software ID on our machine, and this Arduino link helps us to install the Arduino. Now have a look over this and gently insert and install the software. Now get back to the Arduino code, and here is our Arduino code with .in extension. First thing you notice is that we have included wire.h library on our code, and we have defined the address of our sensor, that is 0x40. Now in the void setup function, we have initialized serial communication with the baud rate equal to 9600, and we have begin the transmission here. Now in the void loop function, we have sent temperature measurement command no hold master, that is 0xf3, and we have requested and read 2 bytes of data, and here we have converted the temperature data in the formulas which we have seen in the data sheet for SI7050. At the end of our code, we have output data on the serial monitor, which is in the form of temperature in Celsius and Fahrenheit scales. So this is how our code is. Now let's see how it works with our sensor. Proceeding further, for the working of our code with the sensor, first of all copy this entire Arduino code and open up the terminal for the Arduino. Now here paste the code and save it in the name of SI7050 and verify and compile the code. Now upload the code. As you can see, uploading is in process. Uploading is done. Now let's see the data output on our serial monitor. Now as you can see, temperature in Celsius and Fahrenheit. Now when I press my finger, there is a change in temperature, as you can see. Now again pressing my finger, the temperature changes for Celsius and Fahrenheit scale. So this is how our code works with the Arduino Nano and the sensor. Now let's proceed further. Well, we have just seen the working of sensor SI7050. The SI7050 digital temperature sensor offer industry leading low power consumption and high accuracy across the entire operating voltage and temperature range. This monolithic CMOS IC features a band-gap temperature sensor element, an analog to digital converter with up to 14-bit resolution, signal processing, calibration data, and an I2C interface. The patented use of novel signal processing and analog designs enable the sensor to maintain their accuracy over a wide temperature and voltage range while consuming very little current. It finds its application in HVAC, AR, thermostats, white goods, computer equipment, portable consumer devices, medical equipment, industrial controls, and so on. This sensor can be purchased from our website CONTROLEVERYTHING.com, and the Arduino code is available on the same site. You can have also the Arduino code from our GitHub repository, that is CONTROLEVERYTHINGCOMMUNITY. For further queries, you can contact us on CONTROLEVERYTHING.com, and be sure to post your comments on our community page. For more articles and blogs on these sensors, you can reach us on instructables.com and also on hackster.io. For more video tutorials like this, you can subscribe our YouTube channel. In the end, you have a very good day and thanks for watching.